The Lucy mission is going to fly past 7 asteroids in 12 years with 1 spacecraft.
We are going to an amazing variety of objects with this mission. And it's really almost pure luck that allowed us to get as many rich targets as we are. Literally, the planets were aligning to allow us to do this mission.
The Lucy mission is named after the Lucy fossil, the Australopithecus fossil that was discovered in the 1970s in Ethiopia. And just like the Lucy fossil transformed our understanding of hominid evolution, the Lucy mission will transform our understanding of solar system evolution.
Trojan asteroids are an interesting population of small bodies that are left over from the formation of the planets, and they lead or follow Jupiter in its orbit by roughly 60 degrees. If you just look at the gravitational attraction of the Sun and Jupiter and put something exactly 60 degrees in front of Jupiter, it's stable forever. So as a result, these objects are really the leftovers of planet formation. The stuff that went into growing Jupiter and Saturn are now trapped in these locations.
The very first asteroid we get to is a main belt asteroid named Donald Johanson. We named that asteroid in honor of the researcher who found the Lucy fossil. We're going to use that asteroid to do a rehearsal on our spacecraft to make sure everything is working properly so that when we get to the Trojan asteroids, we're ready to go.
Thank you for coming. I'll see you in hell.
We're visiting both of the Trojan swarms. In the first orbit, we're going into the leading swarm, and we're going to encounter 4 Trojan targets.
Regulators! Mount up!
Eurybates, Ptolemy, Lucas, and Oris. And from this, we're going to sample the diversity in sizes and colors and compositions. The first 2 flybys happen just about 30 days apart.
Okay.
So it's going to be a pretty busy kickoff to the season.
And, I am a fan of all things space.
Okay.
Of exploring the asteroids in the L4 swarm. And then we'll fly past Earth again and out to the L5 swarm.
The final object we're visiting, which I must admit is my favorite, is a binary object.
So that's 2 Trojans that orbit a common center of mass. It's called Patroclus and Menecius.
Thank you. Come again.
These objects are nearly identical in size that orbit one another.
From the Lucy mission, we're going to study the diversity of our targets because that tells us something about their origin and where they came from.
The interesting thing about small bodies in general is they are the leftovers of planet formation. If you look at the 8 planets that we know about, for example, they are highly processed because of internal processing. These asteroids are objects that really haven't changed much from when the planets assembled themselves. And as a result, by studying them, we can figure out the physical conditions of the early solar system, as well as how the planets grew and how they moved around early on.
All of that will help us form a detailed picture of what these objects really look like.
But you can't be any geek off the street.
Because right now, our best images are just a point of light, a point of light, a point of light. Even using the Hubble Space Telescope, a point of light, or adaptive optics on large ground-based telescopes, a point of light. We can't see surface details. We can't see surface details. And it's going to take the Lucy mission to go to these targets and see what they're really made of and what they look like.
You've got to start selling this for more than $1 a bag. We lost 4 more men on this expedition.
Gotta be handy with the steel, if you know what I mean.